Assalamu alaikum students. Today we are going to learn and start a new session with the organic chemistry और ये हम कर रहे हैं for both IGCSE. The subject code 0620 and GCE subject code 5070. So you have to keep that in mind. ये जो ऑर्गेनिक केमिस्ट्री हम पढ़ रहे हैं बेटा, ये दोनों के लिए क्या है, मतलब एप्लीकेबल है. अगर आप इसको सीख लेते हैं सो इट विल हेल्प फॉर द बोथ पेपर्स, दैट इज़ फॉर IGCSE एंड फॉर GCE. सही है. सो सबसे पहले वी हैव टू डिफाइन व्हाट इज़ organic chemistry. Okay, so we have to define it as the study of hydrocarbons and their derivatives. So you have to keep that in mind. Organic chemistry is the study of hydrocarbons and their derivatives. So the next question that may arise is, what are hydrocarbons? So we have to say molecules which are made up of, or we can say composed of, carbons and hydrogen only. So this word only emphasizes that the hydrocarbons are only made up of carbons and hydrogens. Got it? So next we discussed that hydrocarbon is also the study of their derivatives. So what are the derivatives of hydrocarbon? We have to say that a compound in which one of the hydrogen is replaced with any other element from the periodic table like oxygen, nitrogen, sulfur, then the resulting hydrocarbon changes into the derivative of the hydrocarbon. Clear? So यहाँ if we have to practice it out and to clarify the concept, I'm writing few examples and you have to differentiate between these as hydrocarbons or as a derivative of hydrocarbons. Like I wrote CH4, next C2H5OH, C2H4 or CH3Cl. Okay, like another example, CH3 CH2 CH2Br. So you have to differentiate in between these as hydrocarbon or as derivative of the hydrocarbons. Okay, So I try to choose only hydrocarbons. As you can see, this molecule is only made up of carbons and hydrogens. That is why we can say this is a hydrocarbon. Whereas this molecule is also made up of carbons and hydrogens, so it is hydrocarbon. But rest of the three molecules, these include other than carbon and hydrogen. Like this molecule contains oxygen atom, this one chlorine, and this molecule has bromine in it. So we can say these molecules are derived from hydrocarbons and are made by replacing one of the hydrogen from the respective hydrocarbon. That is why these three molecules are called as derivatives of the hydrocarbon. So hopefully you understand what is or what are hydrocarbon and what are their derivatives. So simply हमने क्या सीख लिया? We learned that organic chemistry is the study of hydrocarbons and the derivatives of hydrocarbon. So now we proceeding towards the learning of naming and structures naming and structures. To learn the naming, you all now have to understand the number of carbon atoms. The number of carbon atoms. From now, we have to give them or pronounce it with a different way. Like if we have one carbon atom, that will be pronounced as meth. If we have in a given molecule two carbon atoms, then that will be pronounced as eth. Similarly, for three carbon atoms, it will be pronounced as prop. For 4, it will be as but. I write it but, but will be pronounced as but. For 5 carbon atoms, it will be pent. For 6, it will be hex. For 7, hept. For 8, oct. For 9, non. And for 10, it will be dec. Now we have to learn about the different homologous series. Like first of all, we are going to learn about alkane. In this alkane, you have to keep that in mind. Alk is the representation of number of carbon atoms. Alk is representing number of carbon atoms. Whereas this ane is representing carbon to carbon single covalent bond. Carbon to carbon single covalent bond. Okay, so we have to learn just name, then we will discuss about the structure. So like we said, meth pronouns or meth is used when in a given molecule we have only one carbon atom. So if in a molecule we have only one carbon atom and definitely has all single covalent bonds, it will be called as methane. It will be called as methane. The other one will be ethane. For third, it will be propane. for 4 carbon atom, it will be butane, pentane, and as we proceed it will be hexane, heptane, octane, nonane, and decane. Got it? Now we proceed towards the structures, but before proceeding we have to discuss some few important parts that is related to the bonding. Like we know this is related to all about the carbon and hydrogens, and mainly sometimes we use oxygen as well. So whenever we have carbon, so we know that the proton number of the carbon is 6, indicating it has 2 electrons in its first shell, whereas 4 electrons in its valence shell, and it shows that it can make 4 single covalent bonds at a time. Similarly, for hydrogen we have to keep that in mind. It has a proton number 1 having only 1 electron in its valence shell and needs 1 more electron to complete its valence shell electrons. So hydrogen can make only 1 covalent bond at a time, whereas for oxygen the proton number of oxygen is 8, indicating it has 2 electrons in its first shell and 6 electrons in its last valence shell, and it can make 2 single covalent bonds at a time or 1 double covalent bond. For nitrogen the proton number is 7, indicating it has 2 electrons in its first shell and 5 electrons in its valence shell, and shows that it can make 3 single covalent bonds at a time, or 1 double plus 1 single, or 1 triple covalent bond at a time. Okay, again before proceeding towards the structures, we have to learn about different types of the formulas. Types of formula in organic chemistry. First of all, we have to discuss about the displayed formula. And you have to keep that in mind. The displayed formula means when we show all the possible covalent bonds clearly. So you have to keep that in mind. In displayed formula, show all possible covalent bonds in the given molecule. When we do so, the resulting formula will be called as a displayed formula. Okay, the second format is the structural formula. For structural formula, we have to keep that in mind. We just show each carbon atom along with its directly bonded atoms, right? We have to say write each carbon atom along with its directly bonded atoms separately. Write each carbon atom along with its directly bonded atoms separately. And I will give you the examples when we finish with the all types. Third one is very well known, that is molecular formula. Molecular formula. And for molecular formula, you have to keep that in mind. Write each different type of the atom write each different type of atom in total. Okay, and for fourth, this is the empirical formula. Empirical formula. And for empirical formula, you have to say what? Simplified form of molecular formula. Simplified form of molecular formula. Now, once again, you have to keep that in mind for writing the structures. The total capacity of the bonds that can be made by these different type of the atoms. The second one, you must have to learn what type of the formulas we have. And previously I told you, you have to keep that in mind, the number of the carbon atoms and their pronunciation. Got it? So by keeping all these information in your mind, we are proceeding towards writing the structure and the namings of alkanes. Naming and structure of alkane. Once again, you all have to keep that in mind. In alkane, alk is representing number of carbon atoms, whereas ane is representing carbon to carbon single covalent bond. So you have to keep that in mind. Alk stand for number of carbon atoms, whereas ane stand for carbon to carbon single covalent bond. So starting with very simple molecular or the name, that is ethane. Whenever you are confirmed it is from alkane homologous series, it is advised to start with alk, and you know clearly alk means number of carbon atoms, and in this name it is clear eth stand for 2 carbon atoms. So what we have to do, we have to write 2 carbon atoms separately. Then what is mean by ane? Ane stand for carbon to carbon single covalent bond. Okay, repeating again, eth mean number of carbon atoms, and two carbon atoms, so we wrote 2 carbon atom. Then ane stand for carbon to carbon single covalent bond, and as we know, alkanes are the hydrocarbons. Alkanes are hydrocarbons, means alkanes are made up of hydrogens and carbon only. So eth is completed, ane is completed, And also we have the knowledge each carbon atom can form 4 single covalent bonds. Each carbon atom can form 4 single covalent bonds. Now again, Eth is complete, Ane is complete, so all and rest of all the bonds are completed by placing hydrogens. So when we place the hydrogen atoms, the structure is completed, and now it is ethane. And as we showed all the covalent bonds, this is called as displayed formula. This is called as what? Displayed formula. As we learned, displayed formula is when we show all the possible covalent bonds properly. To write the structural formula, what we have to say? Write each carbon atom separately. Like this is the carbon atom, and we are going to write it separately. You can see this is the carbon atom, and along with this carbon atom we have 3 hydrogen atoms that are. So we are going to write this carbon atom along with its 3 directly bonded hydrogen atoms. So we get CH3, and then the second carbon atom separately along with its directly bonded 3 hydrogen atoms. So we will get CH3 again. Got it? So this type of the formula, when we write each carbon atom separately along with its directly bonded atoms, is called as structural formula. Structural formula. We may show a bond between carbon atoms by placing a single line, but it is more appropriate we must not have to show any bond. The third type we discussed was the molecular formula, and we discussed that for molecular formula you have to write each different type of the atoms in total. So in this we have 2 different type of the atoms. One is the carbon and the other one is hydrogen. So we have 2 different types, carbon and hydrogen. So in total we have 2 carbon atoms, so we have to write 2, and in total we have 6 hydrogen atoms, so we have to write 6. As we connected or writed each different type in total, so this type of the formula is called as molecular formula. Okay, this is called as what? Molecular formula. Then we have to convert this into simplified whole number. What we get? CH3. So this is the simplified form and is called as empirical formula. In some cases, if the molecular formula cannot be simplified into any further, then we have to say both the molecular formula and the empirical formula are same. Remember that if the molecular formula cannot be simplified into any further, then we have to say the molecule has same molecular formula and same empirical formula. Then proceeding another element or molecule, and I'm going to discuss this as pentane. Now you can see, as I told you, whenever you confirm this is alkane, you must have to start with alk, and here alk is pent, and pent stand for 5 carbon atoms. So we have to write 5 carbon atoms initially, 1, 2, 3, 4, 5. Then ane stand for carbon to carbon single covalent bond. And as we know, each carbon atom can make 4 single covalent bonds. So we have to complete all the bonds first. We have to complete all the bonds first. Then, as the pentane is hydrocarbon and has 5 carbon atoms and the carbon to carbon single bonds only, so the remaining all the bonds are completed by placing hydrogen atom like this. Okay, now as we showed all the possible covalent bonds, so this formula is called as displayed formula. This is called as what? Displayed formula. Then we have to convert this displayed formula into structural format. And for structural, what we have learned in the previous example, write each carbon atom separately. And in this specific example, if we choose this carbon atom, so we have to write C along with its directly bonded atoms other than carbon, which are 3 hydrogens. When we proceed to next, so this carbon atom has or connected directly with 2 hydrogen atoms, so we have to write CH2. Next, again we have the carbon atom that is directly bonded with 2 hydrogens, so it will be CH2 again. And in the next, so again we have to write CH2 for this carbon atom as well. And at the end we have CH3. As we wrote each carbon atom separately along with its directly bonded atoms, so this format is called as structural formula. We may write this formula in the shortest version as CH3, and in between the CH3 we have CH2 one time, CH2 second time, and CH2 third time, so we can write it as CH3 repeating thrice. So this CH2 group is repeating 3 times, and by the end again we have to write CH3. So both the formats are acceptable, but I advise you to write this one. Okay, so this is called as what? The structural formula. This is called as what? Structural formula. Now proceeding towards the molecular formula, and in molecular formula what we have to do, write each different atoms collectively. So we have carbon and hydrogen, 2 different atoms. We have total 5 carbons and we have 12 C5H12. Okay, so this is called as the molecular formula. And as you notice, we can't simplify this one, so the empirical formula remains the same. Keep that in mind whenever we can't simplify, the molecular and the empirical remains the same. Clear? Now to proceed forward, we now have to learn, if we are provided with the structural or the displayed formula and we advise to name or write any other type of the formula. So for instance, I'm writing a formula CH3 CH2 CH2 CH2, or by the end I can write CH3. And you are advised to predict what type of the formula is. So as all the covalent bonds are shown, we have to say this is the displayed formula. And from this displayed formula, we can write the name of the molecule. For that, if you are provided with the displayed formula and you have to write the name, first of all you have to notice, is there a single covalent bond? So it confirms it belongs to alkane homologous series. And then you have to count the number of the carbon atoms. So this is carbon 1, carbon 2, carbon 3 and carbon 4. So we have 4 carbon atoms, and we know that 4 carbon atoms can be pronounced as but. So we have to write but. Then as carbon to carbon there is a single covalent bond, so we have to write ane. So the name is completed and we will get butane. Clear? Another example, if now I gave you the structural formula like CH3, CH2, CH3, and you have to write the name. Again, as you notice, each carbon atom is involved in making 4 single covalent bonds. It confirms that it is alkane. And another way to confirm it is alkane or not, you have to remember this general formula CnH2n plus 2, indicating that the molecule which have double the hydrogens as carbon atom plus 2 more hydrogens. So like we have 3 carbon atoms, so it will be C3, and 3 times 2 6 plus 2 8. If this is so, we confirm that this molecule or this formula belongs to alkane homologous series. So as we have 3 carbon atoms and as we have 8 hydrogens, so it is confirmed that this is alkane. When we confirm this is alkane, we have to count the carbon atoms. So as it is very clear, this is carbon 1, carbon 2 and carbon 3. So we have to say this is prop, as 3 carbon atoms are pronounced as prop. And as there is carbon to carbon single covalent bond, so we have to write ane, and at the end we get propane. At the end we get propane. So far we learned how to name, or from the name we learned how to write the structural, displayed, molecular and empirical formulas. And we learned if we are provided with the structure or the displayed formula, how can we name, and how we can confirm is the given molecule is alkane or not. Okay, now we have to discuss few examples with the branched. Okay, so we are going to discuss about the branched chain alkanes or the hydrocarbons. What is the evidence? How can you recognize is the given organic molecule is branched or not? Is you have to learn if there are more than 2 terminals. Like if I am writing this molecule as, so you can see in this molecule we have 3 starting points. In this molecule we have, so in short we can say this molecule has 3 terminals. This one, we can start from this end, we can start from here, this is also the end, and we can start from this end. So this molecule has 3 terminals, and whenever we have more than 2 terminals, we confirm that the given hydrocarbon or the derivative of the hydrocarbon is a branched chain. To name that branch chain, we have to number the long chain of the carbon atoms. As you can see, here we have the long chain of the carbon atoms like these. This is the long chain of the carbon atom containing 3 carbon atoms in the chain. Now we have to number the carbon atoms, but keep that in mind. Always start from that terminal to which the branch is closer. Like you can see, if I start from this end, so it is carbon 1, and at carbon 2 we have a branch. This is the branch. This is not the part of the main chain. Okay, and if I start from the left side, again number 2 is assigned to the branch. So it shows that we can start or we can give the numbering from either side. It doesn't matter at all in this specific situation. So we have to say this is carbon 1, this is carbon 2, and this is carbon 3. So it indicates at carbon 2 we have a branch. So branched chain alkanes can be named as, we have to write first the branch. What we have to do? Write the branch, write first of all, write the position of the branch. Then we have to write name of the branch. And by the end we have to write the parent chain, name of parent chain. Parent chain means the long chain of the carbon atom. Now you have to learn, in our syllabus we have a branch as if there is one carbon atom that is coming as a branch pronounced as methyl. So in short, you have to remember, whenever we have a branch containing one carbon atom, that will be called as methyl. One carbon containing branch. One carbon containing branch. If we have 2 carbon containing branch, then that will be named as ethyl. And for 3 carbon containing branch, we have to name it as propyl. Okay, but mostly in our syllabus only methyl as a branch is considered. So for this specific example, what we have to say, we have a branch at carbon number 2. So the position of the branch is 2. Then we have to place a dash. Then we have to give the name of the branch, as it is only one carbon containing, so we have to say it is methyl. It is methyl. Then we have to name the main chain, which contains 3 carbon atoms, and we learned previously 3 carbons are pronounced as pent. And finally, as there is carbon to carbon single covalent bond, we have to write it as ane. So finally we get the name of the molecule as 2-methylpentane, in which 2 is indicating the position of the branch, methyl indicates name of the branch, and pentane indicating parent chain of the parent chain of the molecule. Hopefully you understand that. Now giving you another example, like if we have CH3, now first of all you have to tell me, is this a branched chain hydrocarbon or not? Pause the video and answer, is the given molecule, this one, is a branched chain or not? Pause the video and answer. And as you know, and as I told you, if we have more than 2 terminals, then that molecule will be considered as branched chain hydrocarbon. So if this is the terminal, this is the terminal, and this is the terminal, so we have more than 2 terminals in this molecule, that is why this is called as a branched chain hydrocarbon. Now we have to number the long chain of the carbon atom. So first of all we have to select the long chain of the carbon atoms. You can see this is the long chain of the carbon atoms. Now secondly, we have to assign numbers to carbon atoms, but keep that in mind. Start numbering to that terminal where branch is closer to the terminal. Like if we start from the right side, this is carbon 1, this is carbon 2, so the branch is attached with carbon number 2. But if we start numbering from the left side, so this will be carbon 1, this will be carbon 2, and this will be carbon 3, and in that case the branch is assigned a number 3, so this is not appropriate. We must have to start from the right side so that the branch get lower number or must be closer to the terminal. So this is carbon 1, carbon 2, carbon 3, and carbon 4. So to give the name, first of all what we have to do, we have to write the position from where branch is attached. So it is clear branch is attached to carbon number 2, so we have to write 2, then we have to place a dash, then write the name of the branch. As branch contains only 1 carbon atom, we have to say it is methyl. Then in the long chain we have 4 carbon atoms, which is pronounced as but, and as there is carbon to carbon single covalent bond, we have to say it is ane. So this is 2-methyl butane. This will be 2-methyl butane. Another example, C, and I'm going to write here CH3, here, and also I have to write another carbon over here. So again, the first question that can be arised in your mind, is this molecule a branched chain or not? So the answer is yes. And the reason, as there are more than 2 terminals, that is why this is called as a branched chain hydrocarbon, branched chain alkane. Now to name, we have to select the long chain of the carbon atom, which is the central part containing 4 carbon atoms. Okay, now we have to assign the numbers. We have to assign the numbers, that is carbon 1, carbon 2, carbon 3, carbon 4. We can't start the numbering from left side. as by doing so, the number assigned to the branch will be higher. So this is the appropriate numbering. Now you can see we have two branches and both are connected to carbon number 2. So we have to say, or we have to write 2, we have to place comma, again 2, indicating that we have two branches and both are connected to carbon number 2. And as both are the same, we have to use the word di indicating 2. And then we have to write methyl as the name of the branch is methyl. Now 2,2-dimethyl indicates we have two methyl groups and both are connected to carbon number 2. And to the long chain of the carbon atom, we have 4 carbons pronounced as but, and as there is carbon to carbon single covalent bond, we have to write ane. So this will be 2,2-dimethyl butane. Hopefully you understand how we can name the branch chain hydrocarbons. Now finally, we also have a closed chain hydrocarbon. You must have to aware of that. Like if I write CH2 and that carbon is connected to another carbon having 2 hydrogens to another carbon atom which is connected to another 2 hydrogens and is connected to the same carbon atoms. So this will close and has no terminal. In that case, this hydrocarbon is called as cycloalkane. This is called as cycloalkane, showing that the structure is a cyclic closed chain. Okay, and as this structure has 3 carbon atoms, so it could be called as cyclopropane. And the structure formula for this type of the molecule will be CH2, CH2 and CH2. Okay, the molecular will be C3H6 and the empirical will be CH2. Similarly, now I'm finishing. Just can you name this one? CH2, 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 CH2 and connecting to the first one. Can you name this one? Yes, you are right. This is cyclobutane. Hopefully you understand and you learn properly. If you have any question, you can ask in the comments and I try my best to answer as soon as possible. Okay, then inshallah I will upload the next video that is related to the naming and the structures of alkene, and then inshallah we will continue and complete the naming and structures of all the hydrocarbons and the derivatives of the hydrocarbons that are related or that can or the part of the syllabus 0620 and chemistry syllabus 5070. So take care of yourself and Allah Hafiz.